All right, so pH homeostasis has to do with acid-base balance. So the blood, the average pH of the blood is about 7.4. So it ranges about 7.38 to about 7.42. So on this end, it's more basic, and on this end, it's more acidic. Okay, so in acidosis, if we get too much this way, too far below 7.38, acidosis can be an issue. In acidosis, the nervous system is depressed, so depresses the nervous system. Nervous system. So you could end up in a coma. Okay. In alkalosis, which is way above the 7.42 number there, we're talking about hyper excitability. So cramping is a problem here. Okay. So there are three ways that the body handles acid-base balance. And the first two we've basically already talked about. So the first way is buffers. So we're talking about bicarbonate. Okay, so this is something we went over in AP1 when we're talking about pH and the buffer system. So hopefully you remember this equation. I've seen it a million times. So CO2 plus water gives carbonic acid, and of course that can be reversed as well. And that can be broken down into hydrogens and bicarbonate ions. So that equation, this side of it, is the buffer system. So if we're too acidic, we can bind up hydrogens, and again, we're talking about pH, and that means we're talking about hydrogen ion concentration. So if we've got too many hydrogens out there and the pH is too low, we can push this equation this way, combine bicarbonate and hydrogens, and make this weak acid, carbonic acid. If we're too basic, then we can break that apart and make that into free hydrogen ions and bicarbonate ions. The buffer system is super fast. It's very fast. It's immediate. It's the first thing that reacts if there's a pH problem. So it's very fast, but it is easily overwhelmed. So the second way that we deal with pH is through the respiratory system. And about 75% of pH homeostasis is controlled through the respiratory system. So we have chemoreceptors that let us know what the pH is. Again, looking at that equation there, we can take carbonic acid, we can break it into water and carbon dioxide, and we can blow that off through the respiratory system. So again, 75% is maintained that way. The respiratory system is fast, not as fast as the buffer system, but is still a fairly fast system. So the last way is through the kidneys. So the kidneys are pretty slow. They're pretty slow, but they're the most powerful. They have the most powerful effect on pH and on hydrogen ion concentration. And within the kidneys, we can reabsorb bicarbonate, so HCO3. If we're too acidic, we can absorb a bunch of bicarbonate. The kidneys can also make bicarbonate, make HCO3 and absorb it. And of course, the kidneys can secrete hydrogens. The kidneys can also reabsorb them, but when we are usually the problem is usually going to be a lower pH number, and when pH is low, we can get rid of hydrogens through secreting them into the filtrate. We can also reabsorb them though. So if we're too basic, they can be reabsorbed. So we're going to talk about exactly how that happens in the different parts of the kidney. So there's hydrogen ion manipulation in the proximal convoluted tubule. So that affects pH in that part of the nephron, and then also in the collecting duct and distal convoluted tubule, where the urine is being sort of fine-tuned. That's also part of that, the pH number there. So the next video, we're going to talk about how that happens.